Next talk is by Chuck Perou, and his talk is on ER and HER2 crosstalk, and as you all know, he's from UNC. Chuck.
All right, thank you. So as Jenny we were talking about here, there's not a huge amount of data on triple positives, and so I thought I would take this opportunity to sort of subset a few data sets in that way and look at what we see, and also, of course, talk about the various subsets that are present within HR positive, HER2 positive breast cancer. So here are my disclosures. And here's an outline for the talk, right? So we'll start with some of the molecular crosstalk, and I'm going to use the term HR positive to represent hormone receptor positives. Forgive me if I call it ER positive occasionally. And then I'll show some data on response and survival. Some of it's very similar to what Nadia just presented, as well as the intrinsic subtype. I think HER2 expression levels within HR positive and HR negatives is also important. And then there's been some interesting data recently on the heterogeneity of HER2 expression or amplification within tumors. And then I'll touch a bit on the tumor microenvironment, which is clearly a very important topic as well. So throughout the talk, I'm going to be probably taking CALGB 40601, which is a HER2 positive neoadjuvant study, and then subsetting it in various ways for illustrative purposes. So here we take the HR positive, HER2 positive subset from this trial. Again, this is all RNA-seq data that we're using, as well as these are clinical biomarkers, though, what we're looking at here. And here are the triple positives, right? So they are the majority class amongst HR positive, HER2 positives. There are a few that are ER positive, PR negative. The ER negative, PR positive group is quite rare, right? And I'll show you, for example, intrinsic subtype on these a bit later, but this group is so rare. But I think the point here is that most HR positives are triple positive, at least in the early stage setting. So this is neoadjuvant data here. And then for molecular data, I always like to refer people to TCGA data. Actually, this was unfortunately buried in the supplemental figure number 18, so you're going to have to look deeply within the 2012 paper. But there was a figure where we looked specifically at all the clinically HER2 positive tumors. So here is ER/PR HER2 status. On the bottom here, we're looking at phosphoproteomics data. And I put this rectangle around, basically, these are the triple positives. You can see there's a few PR negatives in here, but most of the triple positives are of the luminal type. And actually, if you look at the phosphoproteomics data, most of the triple positives are not so positive for what I've highlighted here as phospho-HER2, phospho-EGFR, right? Which you could expect could be a metric of strong HER2-mediated signaling. So I think most people can already appreciate HER2-enriched subtype tends to be ER negative and has the highest levels of HER2 and phospho-HER2, and the triple positives, conversely, tend to have lower expression of HER2 and phospho-HER2. So there's a great deal of molecular data, particularly cell line data, focused around this ER/HER2 crosstalk, right? So within a given cell that's HER2 positive, ER positive, they're actually often EGFR, HER1 positive. And to summarize a lot of data, they're kind of like antagonistic to each other, right? If ER signaling goes up, HER2 often goes down. If HER2 signaling goes up, ER often goes down. And so it gets complicated when we talk about resistance to HER2 targeting or resistance to ER targeting in those that are triple positive. They're kind of each contributing to resistance to the other. And a lot of this work was done by Kent Osborne and Rachel Schiff. Here is a paper from their laboratory looking at many different cell lines, treating them with trastuzumab and lapatinib, and looking at the effects on, of course, HER2 and HER1, and actually HER3 here, as well as on ER signaling. So this particular cell line, MDA MB361, is strongly phospho-HER2 positive, phospho-EGFR, and also ER positive. And when you give trastuzumab and or lapatinib, HER2, HER1, or phospho-HER1, or HER2 go away. ER actually goes up a bit, sort of, again, identifying this sort of, one goes down, the other goes up. If we look at the sensitivity of this cell line to HER2 targeting, either single or dual, or ER targeting, it's largely insensitive to HER2 targeting, even though it's strongly HER2 positive, and it was very sensitive to fulvestrant. And so this led them to say that some ER-positive, HER2-positive breast cancer cells, in this case a cell line, and I'm going to show you some data from tumors, that even though they're HER2 positive, they're largely probably driven by ER, and maybe weakly driven by HER2. And so endocrine therapy might be still effective on these tumors. So in terms of response, in terms of pathologic complete response, here again I'm going to use CLGB40601 as an example. This was neoadjuvant trial giving either trastuzumab and lapatinib, or lapatinib alone with paclitaxel. If we look at the pathologic complete response rate according to hormone receptor status, as is appreciated by many in the audience here, the PCR rate amongst hormone receptor positives is lower than the hormone receptor negatives. In this particular study on the subset, the PCR did predict an improved relapse-free survival. However, within hormone receptor positives in this particular study, PCR did not predict a relapse-free survival difference, whereas hormone receptor negatives it did. So here's a hint that PCR, again, amongst hormone receptor positives, is maybe less impactful than it is in hormone receptor negatives. The finding of sort of the benefit of HER2 targeting and dual HER2 targeting amongst hormone receptor negatives versus hormone receptor positives has been seen in many different studies, and we just saw a few examples in the previous talk as well. So I couldn't give a talk without talking about subtype, so forgive me. And actually, Nadia showed this, I think, this very same slide. So if we look at all HER2 positives, this HER2 enriched subtype is the most numerous. If we look amongst hormone receptor positive, HER2 positive, it is about a third HER2 enriched, luminal A, luminal B, and then certainly amongst hormone receptor negatives, it's largely HER2 enriched. But actually, this is important, and here's where the immunohistochemical surrogates for the subtypes don't do a good job identifying this HER2 enriched subtype, because you can't just say, well, the majority of HER2 positive, hormone receptor negative are HER2 enriched. That's a decent surrogate. You then miss all these other HER2 enriched over here. So back to CLGB40601, if we take the triple positives and now look at their subtype distribution, there still are HER2 enriched subtype samples amongst triple positives. So they're certainly more frequent in those that are ER positive, PR negative, and of the 4 ER positive, PR ER negative, PR positives they were largely the HER2 enriched. But even amongst triple positives, HER2 enriched subtype is still there. And so going back to the TCGA data, and I think the HER2 enriched subtype is particularly important if PCR is the endpoint. And again, we're looking here at the phosphoproteomics data. So here we actually did an unsupervised hierarchical clustering analysis of the reverse phase protein array data. Lo and behold, you get this group that is defined by HER3, phospho-HER2, HER2, and EGFR and phospho-EGFR, and it's largely coincident with the HER2-enriched gene expression subtype. So we postulate that this is the group that is really driven by HER2. And I think that holds up if we look at PCR rates amongst many studies. So this was adapted from this very nice meta-analysis. So here, if we look at PCR rate, not stratifying by hormone receptor status, the HER2-enriched subtype pretty much always has the highest PCR rate. If we now subset to those that are hormone receptor positive, all but one study, still the HER2-enriched subtype, even amongst hormone receptor positives, has the highest PCR rate. So in 40601, if we break it by hormone receptor status, here's what we see. Here's just a reminder, if we look at the pathologic complete response rate, now we're looking at all patients here, not subsetted by hormone receptor status, as Nadia showed in her ADAPT study. Luminal A's have the lowest PCR rate, but they still have the best survival, right? And they have a very low PCR rate, but still nonetheless a very good survival. The HER2-enriched subtype paradoxically is the reverse. It has the highest PCR rate, but oftentimes the worst survival. So if you're HER2-enriched and you achieve a PCR, and you're likely to achieve a PCR when giving single or dual HER2 targeting, then those patients potentially have a good outcome. If they don't achieve a PCR, then it's like a triple negative breast cancer that doesn't achieve a PCR. It's a very aggressive disease, and clearly additional treatments are needed for that subset. Again, contrast it to the luminal A's, right? They don't achieve a PCR, they can still do well in this setting where the patients receive the standard of care. So here's a similar analysis coming from B41, luminal A subtype having the worst, or having the lowest PCR rate, HER2 enriched the highest, and the luminal A's having the best survival. So now let's look sort of subset by HER2 expression levels. So here we're talking about, so when we talk about the mRNA, I use the term ERBB2 to distinguish it from the protein where we typically use HER2. If we look at ERBB2 levels according to intrinsic subtype, they're significantly higher in HER2 enriched, and then at a lower level in luminals, and then still at a lower level in basals. And I do always point out there are basal-like breast cancers that are HER2 positive. And they, if you give them a lot of chemo, they tend to have a good PCR rate, and I'm going to bet it's to the chemotherapy. If we subset by the median expression of ERB2 and take the high group, you can see it's almost all HER2-enriched group. And then if you take the low group, again, this is amongst patients that are all clinically HER2 positive, then here's where the luminal and the basal type shows up. So Nadia also showed this slide. If we're looking at this distinction now of HER2-enriched gene expression subtype and then high for ERBB2 mRNA, work done by Elise Pratt, shows here we're looking at the distribution of so the group we're really interested in is HER2-enriched, HER2 high, and that is quite frequent amongst the hormone receptor negatives And, there's some, it's a third, amongst the hormone receptor positives, but the hormone receptor positives really have lower expression of ERBB2. And this is just a different way of showing the plot that Nadia showed here. Here they did a multivariable logistic regression analysis looking at features predicting outcome. And in a univariate analysis, hormone receptor status does contribute to this. But if you then take this HER2 enriched, HER2 high, it's got a whomping odds ratio here and actually contributes to the final predictions. So if we look at the Catherine study, right, where we're giving the TDM1 to patients with residual disease, I think there was an interesting finding, and we also looked at this here, but I'm going to look at it a little bit differently, right? So if we take those who received trastuzumab alone, those who were mRNA high for trastuzumab, receiving trastuzumab do worse than those that are ERBB low receiving trastuzumab. If they get TDM1, there's no apparent difference. But I think my hypothesis to explain this would be that the ERBB low trastuzumab receiving group is going to be enriched for these luminal tumors, and that the ERBB high group is going to be enriched for the HER2 enriched tumors with residual disease, have this survival plot, and clearly the benefit of TDM1 in that group is huge. So last few slides here, if we're looking, there was a very interesting recent publication from Otto Metzger and colleagues looking at intratumor heterogeneity of HER2. So in this study, patients received neoadjuvant TDM1, pertuzumab, and they did multi-site FISH analysis to look for heterogeneity in HER2 amplification, and identified cases using these criteria that were heterogeneous. Now, they're not super common, but when observed, it was highly enriched for hormone receptor positive cancers. The vast majority of these HER2 amplified heterogeneously tumors were hormone receptor positive. And they had an extremely low PCR rate. So if you look, in fact, it was 0. In this study. So a smaller sample size, but certainly provocative, right? The RCB rate was low, and then actually, if you look at the PCR rate of just all the patients, there are clearly there must have been some hormone receptor positive cancers that did achieve a PCR, but those with the heterogeneous expression did not, suggesting they're not primarily HER2 driven. Right? They're probably hormone receptor positive, potentially ER/PR driven. So lastly, I'll just show a slide or two on the immune microenvironment, which is incredibly important, both prognostically and potentially for predictive purposes. And I'm just going to show you an example, well, here with one of our favorite immune signatures. This we call our immunoglobulin signature, our IgG signature, indicative of the presence of mature antibody-producing B cells. We show signatures all the time. I think sometimes you want to see the genes in the signature is helpful. We call this IgG because like a third of the genes in here are the actual antibody heavy and light chain, as well as other genes made by B cells. Here we've sorted it according to the average expression of this signature. Again, in these HER2 positive patients, the hormone receptor positive patients are enriched in the immune signature low group. Here I'm going to show you similar data in a different way, but for this IgG signature, for a CD4 positive signature, for CD8 positive signature. I could make 100 different immune signatures and they all look like this. So in some ways, there's nothing special about these three adaptive immunity signatures. They're typically always lower in hormone receptor positives versus hormone receptor negatives. And this also tracks along with intrinsic subtype. So the few basals that are in these studies are the ones that tend to have the most immune infiltrates, followed by the HER2 enriched subtype, which often has a lot of immune infiltrates, and then the luminals are typically lower. So in closing, I briefly touched on the complex molecular signaling crosstalk between ER, PR, and HER2, which may contribute to treatment resistance. And again, I already put this in quotation marks here, right? Because being HER2 positive might make you a little less sensitive to endocrine therapy, but potentially not entirely resistant to endocrine therapy. And being ER positive doesn't make you entirely resistant to HER2 targeted therapy, maybe just a little more, or in some cases, maybe PCR is the endpoint, maybe a lot more resistant. So in 40601, PCR was a good surrogate of relapse-free survival, but only in the hormone receptor negative tumors. Here I'll also make the argument that amongst HER2 positive tumors, there are luminal A's. These tend to be many of the triple positives, and they can have good survival despite having a very low PCR rate. And so about 20% of HR positive, HER2 positives are luminal A. So I'll make the argument we may be able to de-escalate in those patients, right? Even though they have residual disease, if they're luminal A, estrogen, ER/PR driven, that is an effective therapy for many of these patients. I do think this intratumor heterogeneity of HER2 is important, as I think, heterogeneity in expression or presence of any predictive biomarker is important, whether it be a somatic mutation or HER2 in this case. And then lastly, hormone receptor positive, HER2 positives tumors tend to be less immune infiltrated. We will certainly someday soon figure out how this might impact prediction of response to immune checkpoint inhibitors within HER2 positive patients. So I'll just end by thanking the many people involved and thank the meeting organizers for allowing me to present today.